Hello friends, welcome to MG Engineers Academy. As of now, we have completed two sessions of Laplace transform, and in last two sessions, we discussed some basic formulas about Laplace. So, I will quickly revise what we discussed last two sessions. So, Laplace transform Laplace. Now, in last two sessions, we discussed equation of Laplace is L of t to integration 0 to infinity e raised to minus st f of t into dt. This is the basic equation of Laplace, and based on this equation, we discovered seven values which we are going to use in upcoming session. So we derive values of Laplace of 1 is equal to 1 on Laplace of e raised to at is equal to 1 upon s minus a. Then we discovered the value of Laplace sin a t equal to a upon s square plus s square. Laplace of cos at equal to s upon s square plus s square. Then we discover the value of sine hyperbolic at equal to a upon s square minus s square. Laplace of cos hyperbolic at equal to s upon square minus s square. And finally we discovered t raised to is equal to gamma function of n plus 1 s raised to 1 plus 1, or we can rewrite this formula this way as well, factorial upon s raised to n plus 1. In both this way you can mention, no any issue. Now based on this some basic, we are now discover, or we are going to solve some example based on this. Okay, so based on these some basic values or formulas, we are going to have some examples. Now first, 4 e raised to 2t plus 5 e raised to 3t. Now we have to find Laplace transform for function. So first example is 4 into e raised to 2t plus 5 into e raised to minus 3t. What you have to do? You have to find Laplace. Laplace of 4 e raised to t plus 5 raised to 3t is equal to. Now by using linearity property means we will it's a plus sign. So I will separate Laplace for this term and this term. Laplace of is to 2t plus Laplace of 5 is to minus 3t. Now 4 is constant, so I will take 4 as outside. E raised to t is here. 5 is constant. I will take it out. E raised to minus 3t. Now what we have now e raised to 80. Now we have the formula e raised to 80, right? What is this formula? Sorry, it is not getting. Now what we have? Formula Laplace of e raised to 80 is equal to 1 upon s minus a. Now we have the same equation here. Now we are going to utilize the same formula in this expression. So 4 e raised to 2t. Here 2 is a constant. What I will get 1 upon yes minus the constant 2, right, plus 5 into same way e raised to minus 3t 1 upon yes minus a is minus 3, right? So 4 upon yes minus 2 5 upon yes plus 3. Now if you want to further simplify it, you can simplify or you can put this as it is. So this is the value of Laplace e raised to 4 e raised to t plus 5 e raised to minus 3t. This is the answer. If you want to further simplify, you can simplify. You can keep it this. Now, second example. What is the second example? Okay, let me take e raised to t to 3t square, right? Now we are going to find the Laplace of 2 minus 2t plus 2 3t. What we are going to do now? we are now using a plus b square, sorry, a plus b bracket square formula. A plus b square formula, square plus 2ab square. So the Laplace of a raised to minus 4t plus 2 e raised to 2t e raised to 3t plus e raised to 6t, right? Laplace of e raised to minus 4t plus e common base, so I will take minus 2t plus 3t plus e raised to 6t. Now Laplace of e raised to minus 4t plus 2 e raised to minus 2t plus 3t e raised to t e raised to 6t. Now by using linearity property, I will separate this Laplace 4t plus Laplace of, I will take 2 as a constant outside to t Laplace of e to 6t, right? So what do we have? Laplace of e to 80 is equal to 1 plus minus a. So 1 upon s minus 4 plus 2 to 1 upon s minus 1 plus 1 upon s minus 6. That's it. If you want to put, if you want to simplify, you can simplify, but this answer is sufficient. Laplace of a raised to t plus 2 3t square. This is the answer. Now third, okay, we'll take 4t cube plus t raised to 7 plus t raised to by 3. Now we have to find Laplace of t cube t raised to 7 t raised to, so now here we have t raised to n, means Laplace of t raised to n is equal to gamma function of n plus 1 upon s raised to n plus 1, or we have n factorial upon s raised to n plus 1. Now you will confuse now. You will think from these two equations. Yes, we have the formula for t raised to n, but there are two formulas for t raised to n. One is gamma function of n plus 1 upon s raised to n plus 1, and n factorial s raised to n plus 1. So which formula needs to use in which case? So let me tell you. Here is one trick. When n is positive integer, then you can use this one. this one. Or simply you can mention n so when is in fraction. So 1 by 2, 2 by 4, 3 by 4, 7 by 4. Okay, if n is in fraction, you simply use this formula. Okay. And in rest of the cases, you can utilize this one and factor upon. Now here 3 means we are going to use this formula n factor upon s raised to n plus 1. And here we have 4 by 3, so we will use this formula. So it's a simple, no need to worry about this formula. Now, by using linearity property, I will separate it L 4 t raised to 3 plus Laplace of t raised to 7 plus Laplace of t raised to 4 by 3. Now I will keep 4 as a constant side t raised to 3 plus Laplace of t raised to 7 plus Laplace of t raised to by 3 4 into 3 raised to 3 means if we are using t raised to 3 then n factorial upon s raised to n plus 1 3 factorial upon s raised to n 3 plus 1 is 3 factorial upon s raised to 4, right? So 3 factorial means, okay, I will mention here 3 factorial s raised to 3 plus 1 plus 1 upon, sorry, now t raised to 7. So what we get n factorial means 7, 7 factorial, 7 factorial upon, yes, 7 plus 1, right? Plus t raised to 4 by 3. So factorial 4 by 3 plus 1 upon s raised to 4 by 3 plus 1. So what we will get 4, 2. 3 factorial means 3 into 2 to 1 upon s raised to 4 plus 7 factorial means 7, 6, 5, 2, 1 s raised to 8, right? Plus 4 by 3 plus 1, 4, 3 into 1, 1, 1 plus 4, 3 plus 4, 7, 7 by 4 s raised to 7 by 4. Sorry, 7 by 3. I just did cross multiplication. If you don't know, I will show it again by this one. Now to get the base denominator same, I will multiply and divide here 1 in 3 5, 1, 2, 3. So I will get this same 3, 4 plus 3, 7, 3. Right? Now 3 into 2, 6, 6 into 4, 24 upon s raised to 4. 7 into 6 into 5 into 4 into 3 into 2 into 1. So it will be 5040 s raised to 8 plus m function of 7 by 3 raised to 7 3. So that's it. This is the answer for Laplace of 4t cube plus t raised to 7 plus t raised to 4 by 3. That's it. Now we'll move to next example. Next example is 2 sin 4t plus 5 cos 2t, right? So we need to find the Laplace of sin 4t plus 5 cos of 2t. Now, by using linearity property, I will separate terms. Laplace 2 sin 4t plus Laplace 5 cos t, right? For the simplification, 2 I will take it the constant outside, sin plus 5 I will take it outside, it's a constant, Laplace of cos 2t. Now, what we have? Laplace of sin at is equal to a upon square plus square. Laplace of cos at is equal to s upon square plus a square. It's equal to, now what we have? We have Laplace of sin 80 is a upon s square plus a square. Laplace of cos 80 is s upon s square plus a square. So we'll just put the values. Sin for t means a. A means 4 s square plus 4 square plus 5 into cos 2t s upon s square plus 2 square, right? 2 to 4 upon s square plus 16 plus 5 3, sorry, 3, it's s square plus 2 square. That's it. 4 into 2 into 4, 8 square plus 16 5 into s 5s s upon square plus 4. This is the answer for uh, Laplace of 2 sine 4t plus u cos of t, right? Now we move next one. Now we are going to solve next problem. Sine 2t cos of 3t. So Laplace of sine t cos of 3t is equal. Now you have to recall 11th and 12th trigonometry chapter. In that we have some standard formulas. So I will tell you 2 cos A sin B. 2 cos A sin B is equal to sin A plus B minus. This is the standard formula. 2 cos A sin B is equal to sin A plus B minus sin A minus B. Now it's a similar to equation. We have Laplace of sin 2t into cos 3t. So we will rewrite as per our formula Laplace, or we can say higher angle will be at the first higher angle means 2t 3t. In this sin and cos, which angle is more? 3t. So I will mention cos 3t to sin 2t. Always remember you should take higher angle first. So now it's in this format. Okay, cos A into sin B means 2 cos A into sin B. Only thing is 2 is missing. So what can I do? I can multiply and divide by 2 to this formula. Cos 3t sin 2t, right? 1 by 2 Laplace of, I will take this 2 side, cos 3t to sin t, right? Now 1 by 2. Now it's in the same format, right? So you can use sin A plus B minus sin A minus B. So sin A plus B, A plus B, A plus B, 3t plus 2t minus sin A minus B, 3t minus 2t, right? 1 by Laplace of sin t plus 2, 5t minus sin t, right? 1 by 2. Now we know the Laplace of sin 5t and sin t means sin 80. A upon square square. Sin 5t a plus a upon is 5 upon a square plus 5 square divided minus 1 upon a square plus 1 square. Right? If you want to simplify it, you can simplify, or you can put this as it is, means it is a answer for the Laplace of sine 2t to cos 3t, right? Next one, cos hyperbolic 8t minus cos of t. We have to find the Laplace for the function. Laplace cos hyperbolic 8t minus cos of t. Now, Laplace of cos hyperbolic 8t. What we have? Yes, of the square plus s square, right? And Laplace of cos bt, it is equal to s upon square plus h square. So we will use the same formula here. Is equal to Laplace cos hyperbolic 80 minus Laplace cos bt. So 80 we have a standard formula, s upon the square minus a square minus cos bt s upon the square plus b square, because here the constant is now b. So this is the answer. If you want to simplify it, you can simplify, or but I don't think so. It's a point to simplify that because the equation will be get longer only. So you can keep this as your answer. Now I will take some one two more example. So I will take Laplace, find the Laplace of function sine square o 40. Sine square 40, right? Now what we need to do? Laplace of sine. Now if you go through this equation which we discovered in last two session, you can see in last session we discovered these values, but here there is no any value which we discovered in the form of square. Now what we need to wait, what we need to do. So we have to find Laplace for sine square for t. So in trigonometry we learned about Sin square x is equal to 1 minus cos x upon 2. This is the formula which we learned in 11th and 12th standard. This is a standard formula for sin square x is equal to 1 minus cos 2x upon 2. We are going to use the same formula here. Laplace of sin square for t. Only thing is here we have the constant 4. So 1 minus cos of 2 is already there. Now here our x term is 4t. 4t, right, upon 2 is equal to Laplace of 1 minus cos of 4 into 2, 80 upon 2, right, equal to, I will take 1 by 2 as a constant, 1 minus cos of 80, right? Now is equal to 1 by 2 Laplace of 1 minus Laplace of cos 80, right? 1 by 2 Laplace of 1, 1 upon s minus cos 80, 80, sorry, cos 80 means we have the formula for cos 80 is s upon s square plus a square h square, right? 1 by 2, 1 upon s minus s upon s square plus h square, 64. You can put it as it is, no need to simplify it further. If you want, then otherwise keep this as it is. That's it. Okay, now what I can do for you, one last example. Let me take it here. Last example is cos cube 2t and the Laplace of cos cube 2t, right? Now, similar way in sin square 4t, we haven't discovered any formula in terms of square, but we make it in our format. So we will have the standard values as per our Laplaces. Similar way, here we have the next problem. In that problem, we have to find the Laplace for cos cube 2t. So same way in 11th and 12th standard, we learned about cos cube x is equal to cos 3x plus 3 cos x upon 4. This is the formula, standard formula for cos cube x. And we are going to use the same here. Laplace of cos 3x cos 3 altogether x is 2t plus 3 into cos of x is 2t upon 4, right? Laplace of cos of 60 plus 3 cos of t upon 4. Now is equal to 1 by 4. I will take it as outside. Laplace of cos 60 plus Laplace of, sorry, 3 Laplace of cos 2t 1 by 4. Laplace of cos 60 means cos 80 means a upon s, sorry, s upon s square plus a square, s upon s square plus 36 and plus 3 2 cos 2t s upon s square plus 4. If you want, you can, okay, further simplify it, square plus 6 plus 3 into 5 15, sorry, so, 3 2 s, here also s 3 into s upon s square plus 4 means s upon 4 into s square plus 36 plus 3 into s upon s square plus 4. You can keep this as it is. If you want, you can simplify it further, but I don't think so. It needs to be simplified. You can keep it as it is, no any issue. So that's it. Today we had discussed some example, basic examples based on the formulae which we learned in last sessions. So if you have any doubt or any request to me solve this problem, I will happy to do that. So just comment me in the comment box. That's it for today. Thank you. Bye.